This we can discuss 2 question lah from this maximum power ni pun dah cukup lah. Okay. Alright, for this maximum power, so maximum power, what is involved in maximum power transfer? Maximum power transfer. This is gonna involve your Thevenin lah, Thevenin equivalent. This Thevenin equivalent will involve the RTH and involve VTH, because the equation for P max is actually equal to VTH squared over 4RL, which is this RL is actually equal to RTH. Okay, clear tak? Hello.
Clear, doctor.
Okay. So first you need to use this equation lah, this equation, in order to find what is your maximum power transfer lah. So before you can substitute all these value VTH and RL, so you need to find lah what is the value for VTH and what is the value for VTH lah, RTH and VTH. So this is involving the Thevenin equivalent circuit lah. Okay. So like for this one, first when you first you calculate for RTH lah. Okay, let's say you want to calculate for RTH. So how to calculate your RTH is that you need to eliminate this power. Okay, when you eliminate the power, so you will have this lah. Okay, and then here is your AB. Okay, your AB here. Okay, so you can find the RTH, which is equal to this RL lah. Okay, so let's say here this is 30k and this is 60k, and here is 10k and here is 60k. Okay, so you will have RTH is this value lah, 20k. How you get it is that first what you have to do is 30k started from here. 30k is parallel with 60k, which is when you calculate you will get 20k, and then this 20k is series with 10. Okay, 20k plus with 10, so you will have 30k, and then 30k again parallel with 60k, right? 30k parallel with 60k, so you will have 20k ohm as your RTH. So this is RTH, which is equal as well with RL lah. Okay? Dapat?
Okay, doctor.
Okay, so now you want to calculate for, you already have the RTH, so now you want to find the VTH value lah. So in order to find VTH value, so you know that this is the terminal A and B, so means that your VTH is here lah. Okay, so this is your VTH. So now let's say here, if you want to solve this, you can solve to get VTH using any circuit analysis, such as you want to use the mesh, node, or you want to use the superposition ke, whatever lah, source transformation pun boleh. So okay, so it's up to you which method you want to use, as long as you get the VTH value lah. But for me, it's easier whether you use the mesh or you can use the mesh, you can use the node, or you can use even the series and parallel resistor punya equation method pun boleh. But here I like to use the what we call it as a node voltage lah. Okay, so because the VTH is here, and then let's say here you put it as V1 lah. Okay, so you will get the equation for this in order to calculate for VTH, alright? So like for this one, you're gonna get the equation, let's say for V1, alright? For V1 equation, what you will have, just make it all leaving the node lah again. Okay, V1 minus 18 over 30k plus with V1 over 60k, and then plus with V1 minus with VTH over 10K equal to 0 lah. Okay. And then VTH node here, you have the two je lah. This one and this part. Okay, what you have is that VTH minus V1 over 10K and then plus with VTH over 60K equal to 0. So you have to solve this equation so that you can get your VTH is equal to 8 lah. Okay. So when you calculate, your VTH is equal to 8. So just use the same method as I shown you the details before lah. For the node voltage tu, just eliminate the denominator for both equation, then you can solve for VTH lah. If you're using the elimination method, you can just simply eliminate V1 and then you can get the value for VTH lah. Okay. Or if you see there is easier way to solve this, you can use any other method lah. Okay. But for me, I think that it's easier to use this node voltage method lah. Okay, so then you get this RTH and VTH. So just use this equation, alright? So your Pmax is actually equal to 8 squared over 4 times with this 20K. Okay, so that you will get your answer is 0.8 milliwatt lah. Don't forget your unit. Okay, dapat tak? Hello?
Dapat.
Okay, one more, last. Okay, last, I'm going to show you the last equation lah. Okay, this one pun sama juga, the way that you want to get the RTH, alright? Just eliminate these both. Okay, eliminate these both so that you will have your circuit like this lah. So this is your circuit lah for this terminal A and B lah. So you have this 2.5K with this 1K and then with this 1K. So what you have here, 2.5K plus with 1K, and then this is going to be parallel with 1K. So that here you're going to have this lah, 777.77 ohm. This is already showing you the answer lah, okay? And then in order to get your VTH, okay, I can see that it's easier for you if you can solve it using the mesh equation, because you know that here, right, you have the super mesh here. Okay, for let's say this one is I1 and this one is I2, so you can solve this by using the super mesh lah. Okay, where you have this as at node 0 here regarding your current ni. So what you have is that you need to have the two equation lah for this one, so that you can get the first equation is you will have this part and this part in the super mesh. Super mesh, you can calculate the whole node here lah, alright, where you have 2.5K I1 plus with 1K I2. Siapa yang ada lab tu, if you want to go now boleh lah. Nanti I just continue je with class. Siapa yang nak leave the class boleh leave the class lah if you have a lab, right? I just continue and then I will send you this recorded video lah. Boleh tak?
Thank you, Doctor.
So this one, okay, 1IK plus with 1K I2 minus with 15 equal to 0, okay, for this first. Then at the super node here where you have the at node 0 here, right? So let's say you have this node lah. Okay, you have this as 3 milli, and here obviously you have I2 and here obviously you have I1. What you have here is actually I1 plus with 3 milli equal to I2 lah. Okay, so you have this as your equation 2. This is your equation 1 and then this is your equation 2 lah. Okay, and then after that, if you simplify this, you will get 2.5K I1 plus with 2K I2 equal to 15. Okay, this is your equation 1. And this is your equation 2. Just solve this equation whether you want to use the substitution method or elimination method. So you can get the answer lah. So if you solve this equation, so you will have I1 equal to but you want to use the I1, I just want to find the I2 value in order to find the VTH here, right? So this is the VTH, so the value that you need to find the VTH. Okay, VTH is equal to here I2 times with this 1K lah, so that you can get your VTH value, right? So you want to find the value for I2. So just directly you can find the value for I2, which is 5 milliampere. And then you can just substitute the value lah. Okay, 5 milli times with 1K, and then you will have your VTH is 5 volts. And then after that, when you find this value, you can just substitute the value, all the value into this Pmax equation lah, where you will have VTH 5 squared over 4 times with your RL, which is this one lah, 777.77, so that you will have your PL is this answer lah. Okay, so you can try to solve this equation lah. For this maximum power transfer, in order to calculate the VTH value, you can use any method lah, any circuit analysis method lah to get the value. Okay.